Yeah, yeah. Hi. Uh, Hi guys. Welcome to lesson 2 of geography series. In this lesson, we are going to learn about origin of universe and evolution of Earth. Before starting to learn about interior of Earth, we need to know about origins of universe and evolution of Earth, how Earth's lithosphere has been formed, how Earth's atmosphere and hydrosphere has been formed. Okay, let's get started. Origin of universe, how universe has been originated. The most propounded and most believed and the most proven theory was Big Bang theory. Okay, what does Big Bang theory say? Big Bang theory says that there existed a tiny ball. Okay, uh, what does this tiny ball have? This tiny ball had indefinite temperature, indefinite pressure, and it is very small. On a whole, we can say that it has indefinite gravity. There existed a large amount of gravitational force in this tiny ball. Okay, gradually what happened? A big bang has been happened. Okay, a big explosion has happened. Explosion. After this explosion, this tiny ball has been scattered like anything. It has scattered into huge space. Okay, and after that scattering, some structures like this were formed, and the scattering has been happening till now. The explosion is such a huge thing that the scattering has been happening till now. So gradually what has happened, the distance between these galaxies has increased. Somewhere here, after this, it will be like this. Okay, this is how universe has been formed, and this formation, that is this expansion, is still happening. And it is most believed theory that how universe has been formed, it is Big Bang theory. Okay, so let us again revise what were the events that happened in Big Bang theory. In the beginning, all the matter forming universe existed in the form of a tiny ball called singular atom. In that singular atom, there is indefinite temperature, indefinite pressure, and it is very small in nature. Okay, after that, Big Bang has happened to the tiny ball. That means an explosion has happened. Okay, after that explosion, what has happened? This tiny ball got expanded. Okay, it got expanded due to that explosion. And the expansion is continuing till present day. Okay, as the size grew, what that means the distance between the galaxies has grew. Some energy has been converted into matter. Okay, what is matter? With the explosion, there is energy. Eh, with the explosion happened, there is energy, and with that energy, the universe started expanding. The one which is very tiny in nature, it started expanding. Okay, with this expansion, the little amount of energy has been converted into matter. What is matter? Anything which has mass and occupies some space is called a matter. Okay, is called a matter. Within the matter, we have atoms and molecules. Based upon the arrangement of these molecules, matter has been divided into solids, liquids, and gases. In solids, the atoms are arranged very tight in a structural lattice. It has been with very little amount of space between them. In liquids, the space between the atoms is more. In gaseous stage, the space between the atoms is much more larger. Okay, Based upon the arrangement of the molecules, matter has been divided into solid, liquids, and gases. How matter has been formed? With the explosion, the little amount of energy is converted into matter. What is matter? Which has some mass and occupies certain space. Okay. Yeah. Within first few minutes of the explosion, the universe has expanded rapidly. After that, the expansion has been slowed down, but it is still continuing. Yeah, that's all. That's all how universe has been formed. Now, let's look into how galaxies are formed. Within the universe, we have many galaxies. Within the galaxies, we have stars. That's all. Let us learn how these galaxies are formed. We already dealt that with the explosion, some energy is converted into matter. Okay, in the initial stages of universe, this energy and matter, they are not uniform. So not uniform. What do we mean by not uniform? In this universe, imagine that it is a universe. There is a little amount of matter here. There is a little amount of matter here. There is some matter here. So it is non-uniform in nature. Okay, it has been scattered in that whole space, and it is non-uniform in nature. Due to this differences, due to this difference, it's quite large in size, it is quite small in size. Okay, due to these size differences, gravitational attraction takes place. We all know that huge body will have large amount of gravitational force, and small body will have less gravitational force. Eventually, the large body attracts, that is the large gravitational force attracts small gravitational force towards itself. Okay. So eventually what happened, this matter got drawn together. This huge amount of matter attracted several small amounts of matter, and all this matter get drawn together. Okay, into one large thing. What does this matter contain? Initially it contained hydrogen and helium, the gases hydrogen and helium. Okay, into one large matter. And eventually this attraction or this coming together of matter started to form galaxies, started to get arranged as galaxies. Why this arrangement happened? Let me explain. Yeah, we just learned that all that matter get drawn together. Okay, when this matter get drawn together, based upon its density, based upon its density, the different galaxies were formed. These galaxies were separated apart based upon the densities. Okay, for example, there must be a galaxy with huge amount of density in the center. The one that has less density than this will be away from the center, and and so on and so forth. Okay, that's how all the number of galaxies were formed. The matter got drawn together. After that, they got separated based upon their densities into the one having large amount of density is in the center or at the center, or one that having less amount of density is away from the center. Okay, that's how different amount galaxies are formed. What does these galaxies contain? Initially hydrogen and helium. Okay, now within this galaxy, okay, within this galaxy which contains hydrogen and helium, that predominantly hydrogen, within these galaxies there are localized lumps of gases. What do you call as localized lumps of gases? So it is a galaxy. Within this galaxy we have certain localized lumps of gases. Localized means they are located in a certain point. These gases, the gases have been localized at certain points. This is some amount of gas. 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 So these are called localized lumps of gases. Okay. And uh, yep. Where were we? Yep. Uh, Localized lumps of gases. Eventually, what happened? These localized lumps of gases grew denser. They became denser, uh, denser, and a core has been formed. Okay, this core, uh, uh, how this got denser means their hydrogen, right? We just learned that these galaxies are hydrogen and helium. Okay, within this there's localized lumps of gases. These localized lumps of gases contains hydrogen. Eventually it got denser. Here denser means these uh, hydrogen contains protons, right? These protons got fused. Okay, there is a nuclear fusion happened here. This nuclear fusion formed into a core. Whenever a fusion happens, some amount of energy is oozed out. It or some amount of energy is exported, and it is exported in form of light. And these localized lumps of gases with nuclear fusion that's emanating light, that emanating energy in the form of light, are called as stars. Okay. uh, is it clear? Galaxies contain localized lumps of gases. Eventually, these gases got denser. How it got denser? The hydrogen with the hydrogen molecules, or the hydrogen protons, got fused together. This Because of this fusion, there is energy, and this energy emanated out in the form of light. And these localized lumps of gases that where fusion has happened and uh, giving light as an energy are called as stars. This is how stars are formed. We just learned how universe has been formed. Within the universe, the matter got drawn together and galaxies were formed. Within the galaxies, there is localized lumps of gases. These localized lumps of gases got denser due to fusion of hydrogen molecules, and light has been emanated from it. So the localized lumps of gases which emanates light as energy are called as stars. So there are huge amount of stars within a galaxy, and a huge number of galaxies form a universe. Okay. And yeah, I forgot. I'm sorry. Uh, we uh, we learned that within the universe, the matter got drawn together and formed galaxies, right? The matter is nothing but hydrogen and helium. Yeah. um, the matter getting drawn together and forming a structure is called as nebula. This is called a nebula. Initially it is a nebula. Okay. After that, this nebula got divided into galaxies. Within the galaxies there are stars. This is nothing but a large cloud of gases. Okay, the matter got drawn together. The matter nothing but gases. They are got drawn together and formed into a large cloud of gas called as nebula. Yeah, we just learned how universes formed, galaxies are formed, stars are formed. Now let's see how planets are formed. Okay. Um, uh, for uh, for evolution of planets, there is an early theory called as nebular hypothesis. by Immanuel Kant. Uh, what does nebular hypothesis say? Nebular hypothesis says that these planets are formed from a cloud of gases with a youthful sun. Nebular hypothesis by Immanuel Kant says that uh, planets were formed out of a cloud of gases which is associated with a core. This core is nothing but a youthful sun. Okay, so what does nebular hypothesis say? Planets are formed from a cloud of gases with a youthful sun at the center. Yeah, it's just a theory when Immanuel Kant has proposed. After that, scientists have discovered, based upon lots of studies and lots of material gathering from the universe, scientists have came to a theory how planets were formed. Let us look into that. And the theory proponent by scientists is somewhat similar to the one proposed by Immanuel Kant, that is nothing but nebular hypothesis. Okay, yeah. Let's look into the modern explanation for planets formation. We learned that these stars are localized lumps of gases, right? Within a galaxy, these stars are localized lumps of gases. The gravitational force within these lumps of gas led to the formation of a core. Okay, formation of a core with a disc-shaped rotation of gases around it. The gravitational force within these lumps of gases led to the formation of a core. How does core form? Core forms by accumulation of nuclei or proton or hydrogen atoms per se. Hydrogen atoms, that means nuclear fusion. Through nuclear fusion, a core has formed, and around this core, a huge rotation disk of gases has been formed. A core with a huge rotational disk of gases has formed. What happened in the next stage? The gas cloud, we said that it has been rotating. Okay, eventually the rotation gets slower. When the rotation gets slower, gases get condense. Why? Less rotation, temperatures will reduce, and gases will condense. What does condensation mean? Um Conversion of gas into solid is condensation. Conversion of gas into liquid is condensation. Conversion of liquid into solid is also condensation. Okay, temperatures will reduce and these gases started condensing. Okay, and after condensation, what has happened? This is core, and after condensation these gases get solidified and formed as small objects around the core. So, let me use another ink. After condensation, the rotational disk of gases formed into small objects around the core. Okay, like this. Okay, uh, these small objects after condensation were nothing but planetesimals. These planetesimals acted as nuclei for planets. That is, these were the initial structures for the planets. Eventually, these planetesimals got evolved into planet. How? Let us look into it. After condensation, around the core, planetesimals has formed the gas is converted into solid, that's why it's called condensation. Okay, these planetesimals are solid in nature. After planetesimals has formed, the small planetesimals, um, they are not uniform in size. Some planetesimals are large, some are small, and eventually through gravitational attraction, um, these planetesimals got collided. Okay, got collided and attracted towards each other, formed into large masses around the core. This is core. Okay, these small planetesimals, due to collision and gravitational attraction, formed into large objects due to collision and gravitational attraction, formed into larger objects. After that, accretion has happened. What does accretion means? These large objects are there, right? They got accreted, they got uh, uh, how shall I say it? Uh, Accretion means nothing but they fuse it together. These bodies fuse it together. These large planetesimals fuse it together, forming a planet around a core. Okay. Uh, we have studied that planets are formed. We are not talking about how solar system is formed. These kind of events happen in each and every galaxy. There might be many number of planets in other galaxies also. Okay, we just learned how planets are formed. How planets are formed? Localized lumps of gases within a nebula. Okay, these localized lumps of gases eventually got denser with a core and a rotational disk of gases around it. Okay, eventually the rotation got slower, temperature reduced, and the rotational disk of gases got condensed into small objects called as planetesimals. After that, due to collision and gravitational attraction, these small planetesimals got due to collision, gravitational attractions, larger planetesimals are formed due to uh, fusing of small planetesimals. Larger planetesimals are formed. Eventually, due to accretion, these large planetesimals got fused together and evolved as planets with a core at the center of it. Okay, this is how planets are formed. Now let us look into solar system. How solar system is formed? Similarly, initially there is a core and planets surrounding it. Planets surrounding it and rotating around the core. Okay, this is the core. What's happening in this core? This core is emanating energy due to nuclear fusion in the form of light. That's called sunlight. This core is nothing but the sun. As nuclear fusion is happening, it's emanating energy and it is formed from localized lumps of gases. It is called as star. That's why we call sun also as a star. Okay. These planets are formed initially. In solar system with a core and the planets are formed. What does our solar system contain? Our solar system contains a sun, eight planets, and around I think 63 moons. Okay, out of the eight planets, Mercury, Venus, and Earth are called as inner planets. Jupiter, uh, where am I? In inner planets, sorry, wait, or terrestrial planets. Uh, and after that, from Jupiter to Neptune, they are called as outer planets or Jovian planets. Okay. Why this differentiation? Why terrestrial planets and why Jovian planets? Jovian means nothing but Jupiter-like. Okay. Initially, with sun at the center, and their planets, right? Each in different size, not uniform in size. Okay. Uh, due to solar winds, the primordial atmosphere of first three planets got disappeared. Okay. Let me explain in detail. Initially, all the eight eight planets have similar atmosphere with a thick atmosphere of hydrogen and helium. Initially, all the eight planets had a thick atmosphere consisting of hydrogen and helium. Okay, due to solar winds, uh, this hydrogen and helium amount of the thick atmosphere got I don't let's not say it is separated. Um, the solar winds blew off the initial thick atmosphere around Mercury, Venus, and Earth. Okay, the primordial thick atmosphere has been blown off by solar winds. This kind of event did not happen from Jupiter to Neptune. Why? First thing, they are far away from the sun. Jovian planets are far away from the sun. They have they are larger in size, so they have high gravitational force. This high gravitational force helps to hold atmosphere together. Okay, but Mercury, Venus, and Earth are nearer to sun and less gravity. That's why, as they are nearer to sun, the solar winds blow off the thick atmosphere, and due to their less gravitational force, they are unable to hold that atmosphere together. They are unable to hold that atmosphere together due to less gravitational force of Mercury, Venus, and Earth. Yeah. So, as the primordial atmosphere of Earth, Mercury, Venus, and Earth has been blown off, the planet is the solid, barren, rocky thing is left. That's why they are called as terrestrial planets. As the thick atmosphere of from Jupiter to Neptune was not blown off by solar winds, they are gaseous in stage and are called as uh, Jovian planets or Jupiter-like planets or gaseous planets. Okay. Now, yeah, we have covered universe, galaxy, star, planets, solar system, and after that, moon. Uh, Modern theories have suggested that Earth and moon were like this initially. Oh, sorry. in a dumbbell shape. Okay, this is earth and this is moon. Okay, this is initially. And scientists said that after this, for this arrangement, a big splat has happened. Splat, nothing but an explosion has happened. Due to this big splat, these two got separated, and the explosion is such huge that a structure like this has been found, with Earth rotating around the sun and Moon rotating around the Earth. Due to big splat, the dumbbell shaped structure got separated like this, with Moon rotating around the Earth. That's all. That's how Moon was formed. Now let's talk about how evolution of Earth. Yeah. uh, we will learn that Mercury, Venus, and Earth, the primordial gas have been blown off. Let's pick it from there. Initially, Earth has thick atmosphere. Okay, this thick atmosphere is nothing but hydrogen and helium. Okay, due to solar winds, the primordial atmosphere has been blown off. Okay, has been blown off. Yeah. After this, what is the condition of the Earth? After this, after the blowing of the gases, the condition of Earth was somewhat like this. Earth was barren, rocky, hot, and with a thin atmosphere of hydrogen and helium. What was initial condition of the Earth? Barren, rocky, hot, with thin atmosphere of hydrogen and helium. This is the initial condition of the Earth. Okay. After that, due to many events, the Earth got layered structure with a core and atmosphere. Okay, with varied densities. There is a large amount of density at the core and very less amount of density at the upper stage of the atmosphere. How this layered structure has been found, we will talk about it now. How a layered structure in the Earth has been formed. Let's talk about it. Okay, after this initial stage, that's barren, rocky, and hot. Um, um, how can I say that? Due to accretion or fusion of molecules, density of the Earth got increased. Density of Earth got increased. Okay. As a result, material inside the Earth got separated according to its density. Okay, density of the Earth increased. After that, inside the Earth, this is after the density got increased, the materials inside the Earth got divided according to the densities. That means there is a core, okay, at the center, Above this there is mantle, and above mantle there is crust with varied densities: high density, medium density, low density. Okay, inside that this thing got happened where materials got divided according to their densities. Okay, the one which large amount of density, the okay was at the center with less density above it and much more less density above that. Okay, eventually temperature has reduced, cooled down, so that the outer part got solidified. Outer part got solidified and formed crust. Okay, so due to uh, increase in the density and due to cooling down of the earth, there are layers as formed, like with crust, low density of the crust at the upper middle there is a mantle with much more density, and at the center there is higher density called core. This is interior of the earth with crust at the outer part. Now let us look at how atmosphere of the earth has formed. uh, we have learned that the thick atmosphere has been blown off due to solar winds. Okay, and after that cooling down has happened. After the cooling down has happened, uh, these gaseous interior of earth, gaseous interior of earth started degassing. Okay, what is degassing? It started oozing out gases. The interior is very hot. Okay, and eventually the temperatures reduced and earth got cooled down. And degassing has happened. The gases have been oozed out. Let me explain. If there is hot water and when you put a solid ice on the hot water, vapor comes out, right? Okay, that is called degassing. The interior of the earth was very hot due to reduction of the temperatures. Degassing has happened, that gases have been moved upwards and formed atmosphere. After degassing, atmosphere has been formed. This initial atmosphere uh, mostly contained water vapor, nitrogen, methane, carbon dioxide, very little amount of oxygen. Okay, after this further cooling down happened, crust got solidified. Okay, and crust got solidified, and due to uh, plate tectonics, we will learn about it in continental drift theory, don't worry. Plate tectonics, volcanic eruptions happened, and these volcanic eruptions did two things. First thing, they cooled down earth further, and also contributed to add gases. Oh, wait, contributed to add gases to atmosphere. Why volcanic eruptions cool down the temperatures of earth? During volcanic eruptions, sulfur dioxide is released in huge amounts. This sulfur dioxide, like, it forms as a huge cloud. Okay, these sulfur dioxide clouds block sunrays. Okay, and cooling down has happened. Due to this cooling down, we learned that the initial atmosphere contains water vapor, carbon dioxide, and other gases with very little amount of oxygen. The water vapor got condensed. Wait, vapor got condensed. What happens when vapor got condensed? Clouds will be formed. Okay, this is vapor in gaseous state. Cooling happened. The gaseous state converted into liquid state called as cloud. When clouds get heavier, they pour down as rain. Okay, clouds are formed. Precipitation has happened. This precipitation did two things. One, one thing, oceans are formed. Further cooling down happened. This further cooling down, again condensation happened. More rainfall. That is more precipitation. And due to more precipitation, more oceans are formed. Okay, within the oceans, first life has evolved. First life has evolved in the form of a unicellular organism. This unicellular organism started fixing carbon dioxide. Oxygen is released. Okay, oxygen is released, and after that, within the oceans, plants are formed, and due to photosynthesis, more oxygen released in oceans. At certain point, oxygen got saturated in the ocean. Got saturated in ocean. Okay, saturation means there is a certain limiting capacity for any body or any matter to hold certain things. um, let's say, if there is a human being of 6 feet height, uh, he can only withstand a weight up to certain amount, that like around 90-95 maybe. After that, he cannot hold that weight and become obese next death, right? Similarly, oceans have certain carrying capacity. Only certain amount of it can only hold certain amount of oxygen. Okay, if that upper limit is reached, we say that saturation has reached. Okay, um, after saturation has happened, the extra oxygen released outwards, and life formed on uh, let's say not life formed on, let's say wait a minute, let us say terrestrial life has formed. Okay, that's all. From this we after this we will learn about interior of the earth, how oceans and continents are formed. Yeah, thank you.